for those of you that were here the other day, we talked about the mighty lakes as our review. The mighty lakes. Molarity times liters is what? Moles. Molarity times liters is moles. Molarity times liters is moles. Okay? I want everybody to look. You have a volume and a molarity. You have moles. You have a volume and a molarity. You have moles. Moles of what, Ms. Matney? Well, technically moles of sodium hydroxide and the sodium spectate. So hydroxide. And you have moles of iron 3 nitrate. But the nitrate spectates. Push it to the side. And you weren't even here, Hayden. You go. All right, so molarity times liters is going to give me moles. That's the very first thing I have to do, and I have to do that twice. Why? Because I got twos. I got one there, one here, so I got to do that twice. I got to get moles of my hydroxide first, and then I got to do it second, and get moles of my iron second. Yes? Now, back to Unit 2. What we're doing is we're figuring out how many moles of hydroxide are in this beaker and how many moles of iron 3 are in that beaker, so that when I all of a sudden mix them together and I have iron 3 and hydroxide, and I know their number of moles, floating around together in total volume, I can say, stop the clock. Let me see what I have initially. So molarity times liters will give me moles. And if I'll take that number of moles and divide it by total volume, I will know what's the molarity of my iron 3 initially, and what's the molarity of my hydroxide initially. So once I get moles, I need to do what, Hayden, with the mole values?
You have to
Divide them by what? Total volume. Now, is total volume 0.06 liters? It is, because what is 20 plus 40? What is 40 plus 20? It's 60 milliliters, and how many liters is that? 0.06. So what you're doing in the very beginning of this problem is you are taking the moles of the hydroxide from sodium hydroxide and the moles of the iron from the iron 3 nitrate, and you're dividing each of those mole values by your total volume of 0.06 liters. To do what, Ms. Matney? To know your initial concentrations of the iron 3 and the hydroxide for your ice chart. For the ice chart. All right, so let's do that real quick. Let's take our 0.02 liters and multiply that by 0.02 molar to give me 0.004 moles of hydroxide. I'm going to ignore the sodium. He's there, but I'm ignoring. If I'll divide that by my total volume, I get a value of 2/3, so that's 0.0067 molar hydroxide, OH minus. Okay, that's one. That's one ion. Molarity times liters, divide by total volume. Molarity times liters, divided by total volume. But then I say we had to do that twice. We had to do it once for hydroxide, now we have to do it for iron. So I do it with the iron and I say 0.04 liters times 0.003 molar And that gives me a value of 0.00012. 0.00012 moles of iron 3. And if I divide that by 0.06 liters, that gives me 0.002. And that is of iron. Now, let me just stop a quick moment. That's Unit 2. All of that right there is just a Unit 2 review. Molarity times liters divide by total volume. Molarity times liters divide by total volume. Anytime you're taking two solutions and mixing them, molarity times liters divide by total volume. To get the initial molarities when they're together. When they're separate and they have their own known molarities separate, they're not touching, they can't react. They're not touching. So I have to know what are they when they're together. And see, are we going to have enough ions floating around that there's a precipitate gate? Totally different question from what we have seen today so far. So let's do this. Let's kind of bring it up just a little bit, little space. Let's write down the FeOH taken 3 times, solid. Didn't I say you needed some space for this question? Fe plus 3 and 3 OH minus. Now, this is different because what side am I starting on? The right side. I'm starting with ions. I'm starting with no solid. Wasn't the question, will a precipitate occur? Will a solid be made? Isn't that what it asked me? All right, that's a clue in that it's a Q question, but that also is giving me the idea there is no solid initially. Initially, there's no solid. Well, what is there initially? Ions, right here. Ions, 0.002 and 0.0067. Molar values. Now, I know what you want to do right away. Don't do it. You want to go minus 3x, minus x, plus x, don't you? And that's normal, that's natural. But does it even need to do that? Question, doesn't need to do that. Question, the Q problem. Q means you've got to plug in your values into the KSP expression, but don't call it KSP. Don't call it KSP, don't call it Q, and then compare KSP to Q. And decide then, does it need to shift towards the solid side? Or does it just stay at the initial spot and just kind of float around? I don't know, let's go see. Q says this, concentration of iron times concentration of hydroxide cubed. So let's put those numbers in, those two numbers, 0.002 to the first, 0.0067 to the what? Thank you, to the third. And I get a value of 5.9 times 10 to the minus 10. And what did we say that KSP was from the other side? We said the KSP was 3.8 times 10 to the minus 38. All right, so let's do what we did before. Let's bring it up just a touch. All right, so how do KSP 10 to the negative 38 and Q 10 to the negative 10, how do they compare? Q is bigger. Which way is my arrow pointing? That means I'm going to make some solid. That means I am going to have a precipitate form. But let's get down to the nitty-gritty. Why? Because there's more product than KSP allows, yes. Too many ions floating around. KSP is the gatekeeper. KSP is the fire marshal down in the gym. KSP is the one that says, oh, no, too many ions floating around. Some of you better come out now and reach an equilibrium. So let's show, we're not going to solve, I promise we'll never solve. But let's show what that ice chart would look like. So in order for me to do that, I got to grab an eraser, just take this away. Okay, so here's our ice chart. We've determined that it's going to shift left. So let's do the C. Let's do the C and then the E. Ready? Minus what? 3x minus what? X plus what? X. So at equilibrium, you'd have X moles per liter. I know that the solid's not really sitting, but it's X moles per 1 liter. You'd have 0.002 minus X here, and can't squiggly here. There's too much of a difference between Q and KSP. You can't squiggly here. You can squiggly when we're going the other direction, not this direction. That's why we're not going to solve it. That's technically what happens. And so, yes, a precipitate, which is solid, is going to forms. That's what that means. That's what the Q questions in KSP mean.